Welcome to solverfy.
We have a paragraph of information about printer failures, and let's look at the probabilities first. The probability that a printer failure is due to a hardware problem is 0.1. The probability it is due to a software problem is 0.6. The probability it is due to something else, other, is 0.3. So we have everything covered here. These add up to 1, as we'd hope. This is what we call partitioning the sample space. Every problem is one of these 3 options, and only one of them. They are complementary to each other. Okay, so these are the probabilities of having particular problems. The probability of a printer failure, given it's a hardware problem, is 0.9. So if you have a hardware problem, the probability of a printer just fails is 0.9. Failure given software is 0.2. So printers with software problems are much more likely to keep functioning. Probability of failure given other is 0.5. Now, so a customer says there is a printer failure. What is the most likely cause of the problem? So for this, we are going to be comparing the probability of it being a hardware failure, given the printer failed, to software, given the printer failed, to other, given the printer failed. If I didn't know the printer failed, if you just said my printer has a problem, I could look at this and say, well, most likely it's a software problem. But since software problems are less likely to cause failure, knowing that there was a failure of the printer changes things. So how can we find this? Well, when you want to flip conditional probability, you are looking at Bayes' theorem. The probability of B given A is equal to probability of A given B multiplied by B divided by A. If you apply that to these, you could get the probability of something given failure. So let's look at hardware, for example. Failure given hardware, we have that. Hardware, we have that. Divided by probability of failure, which we don't currently have, we could find by taking a kind of weighted average here. So what we're saying is, out of all of a failure, this proportion is due to hardware. This is the intersection. Failure and hardware. And you could do this for the rest of them. We'd have 0.6 times 0.2. We'd have 0.3 times 0.5. I'm saying we would because we don't actually have to calculate this. Looking at these 3 calculations I've written out, the probability of failure can also be partitioned into 3 groups. It's either a failure and hardware, or a failure and software, or a failure and other. So I just need to know which of those is a greater proportion of the failures. And for that, we're just going to look at these numerators. 0.01, 0.09 rather, 0.18, 0.15. From this, I can see, oops, that is not correct. That is not how you calculate things. 1, 2, there we go. From these, I can see that this will be the greatest probability here. So the answer is other. And you could calculate these if you want to feel more secure in your answer. I can see that if you add up the numerators, you get the total probability of failure, which is 0.36. Yep. So it's these out of 0.36. The probability of a particular failure, a particular problem, given that it caused a failure.